A lot of people deal with sinus problems every year, but analyzing CT scans of the nose is still very slow. What if AI could help speed that up? One way to do that is by using AI, but AI needs good, well-labeled data to learn from. That's where the NasalSeg Dataset comes in. It's a collection of sinus CT scans segmented by expert. Here's a quick overview of what I'll cover in this video. First, I'll introduce the NasalSeg Dataset and explain why it matters. Next, I'll show you how to download the dataset and extract the files. Then, we'll load and explore the CT scans and their segmentation labels inside 3D Slicer. I'll also explain how to convert the data into NumPy format so it's ready for AI and deep learning projects. We'll look at some real-world clinical applications, like how this data can help with surgeries or research. After that, I'll explain why this dataset is fair and open source, making it easy and practical for anyone to use. And finally, I'll wrap up everything with a quick summary and share some final thoughts. By the end of this video, you'll know exactly how to get started using the NasalSeg dataset for your own project. I want to share a useful dataset that I found while looking for medical imaging data. It's called the NasalSeg Dataset, and it's a full collection of CT scans of the nose and sinuses, all fully labeled by experts. This dataset can be very useful if you're working on AI-based segmentation, anatomy studies, or even surgical planning tools. It's completely free and open to use, which is great. So, let me walk you through what it is, where to get it, and how to actually use it. This dataset was published in 2024 in the journal Scientific Data by Nature by Zhang and their team. They put together 130 high-resolution CT scans, all stored in NRRD format. These CT scans were collected as part of clinical assessments, likely for patients with sinus conditions. What makes this dataset relevant is that sinus CTs are used in ENT clinics to plan surgery, assess chronic sinusitis, or investigate nasal obstructions. Each scan is carefully labeled, pixel by pixel, to show 5 different regions. That includes both left and right nasal cavities, the nasopharynx, and both left and right maxillary sinuses. So if you're doing anything that requires precise segmentation, this dataset can save you hours of manual work. And it's not just images, it's high-quality annotations too. We'll see exactly what that means when we open it together later. All right, let's look at how to get it. You can download the PDF of article and the dataset directly from Zenodo. If you scroll down to Data Records section, there is a link to download it. Now here you can download it easily with this link down below. I'll share the link in the caption of this video. It comes in a zip file, and when you extract it, as you can see here, you'll find 2 folders. The first is the main folder named Images, and the second is called Labels. As you can see, all of the files are in NRRD format, and each folder contains 130 files. Now let's open it in 3D Slicer. This is a free app, and I'll put the download link down below. It's one of the best tools for viewing and editing medical images. You can load the file by clicking Add Data. Then you open the Images folder and select one of the files. I'll choose the first file. Leave the description as volume and open it. Now you can see the first CT scan in 3 different angles. Red is axial, green is coronal, and yellow is sagittal. Here I'm scrolling through the CT scan. This is like slicing the head from top to bottom. If you double-click, it shows the file in a larger view. Now for adding labels, you click Add Data and select the corresponding segmentation for the first image. This time, select Segmentation for the description and then click OK. You'll notice these colored areas popping up. Those are the segmentations. They highlight different parts of the nasal anatomy, like the left and right nasal cavities, the maxillary sinuses, and the nasopharynx. These masks can be helpful because they allow researchers or AI models to quickly identify key structures without needing a radiologist to mark them manually. Now let's take a look at the data in 3D. First, we select Volume Rendering from the Module tab, and then make sure our volume is selected and click on the eye icon to turn the visibility on. Now look at the top right section. This section is for showing the data in 3D. If you select Center View, the image is now in 3D. You can rotate it and also zoom in and out. It's pretty interesting that you can see the actual image. Now, if you go to Segmentations from the Module tab and click on Show 3D, the segmentations appear too, but because of volume, you can't see segmentations properly. Let's turn the volume off to better see the segmentations. For this, we again go to Volume Rendering and click on the eye icon. Now you can see the 3D view of just the segmentations. You have the ability to keep some on while turning others off. If you're planning to use this data for AI, like training a deep learning model, you'll probably want it in NumPy format. Let's take a quick look at this Python script. The goal here is to convert a medical CT scan files, which are in NRRD format, into NumPy arrays, so we can work with them more easily in Python. First, we import the OS, NRRD, and NumPy libraries. Then we set the folder where our NRRD files are stored, and we create a new folder inside it called Converted NumPy to save the output. The script loops through all files in the input folder and checks for those that start with the letter P and end in mg.nrrd. For each matching file, it loads the data using the nrrd read function, which gives us both the image data and some metadata. We then save just the image data as a NPY file using np.save, which is efficient format for working with large arrays in Python. And finally, we print out a message to confirm each successful conversion, or show an error if something goes wrong. Now let's talk about where this is actually useful in real life. In ENT clinics and surgery, 3D models of the sinuses are extremely important, especially for planning operations or studying chronic sinus problems. When a surgeon can clearly see the exact shape and location of each sinus, they can avoid complications and make better decisions. This type of imaging is especially important for conditions like chronic rhinosinusitis, nasal polyps, or structural issues like a deviated septum. Accurate 3D data helps doctors plan surgeries more safely and even predict how effective a treatment might be. The NasalSeg Dataset makes it much easier to build those kinds of models, or even AI tools that can automate the process. It's also valuable for research into nasal airflow, inflammation, or structural deformities. So yeah, it's not just academic, it's practical. Now let's evaluate NasalSeg Dataset using the FAIR principles that stands for findable, accessible, interoperable, and reusable. It's definitely findable. It's published on the Nature website with its own DOI, so it's easy to locate and cite. It's accessible too. The full dataset is publicly available, with no login required and open metadata. For interoperability, the files are in NRRD format, a standard used in medical imaging. You'll need something like 3D Slicer to open them, but that software is free and widely used. And finally, it's reusable. It comes with a Creative Commons license, so you're free to use it as long as you give proper credit. That's pretty much everything you need to get started with the NasalSeg dataset. Today, we looked at what this dataset is, where to find it, and how to actually use the files inside 3D Slicer. I also showed you how to convert the NRRD files into NumPy arrays if you're working on AI models. Plus, we talked about some practical, real-world clinical uses. In the end, this dataset isn't just a bunch of CT scans, it's a real tool for innovation. Whether you're building AI segmentation models, planning surgeries, or researching nasal airflow and anatomy, having clean, expert-labeled data like this can save you tons of time. What makes it even better is that it's totally free and open source, following the FAIR principles. That means it's easy to find, simple to use, and licensed for anyone to work with, whether you're a researcher, clinician, or developer. I personally think datasets like this are exciting because they're not just locked away for big companies. Anyone can access and use them to help improve healthcare. So if you're interested in medical imaging or AI, I really recommend checking out the NasalSeg Dataset for yourself. Thanks for watching. If this video helped, don't forget to like, subscribe, or drop a comment below. And if you're using this dataset in your own project, let me know. I'd love to hear about it. See you in the next video.